One I use most often is the sbatch command. With this command, you submit your program, sometimes also called job, to the scheduler, and it decides when it is run. Let us link it back to the theoretical part. We've seen that you log into the front end, that you make the Slurm job submission, and the Slurm controller, who lives on a separate node, will decide when and on which node your job will be run. How does this look in code? Well, instead of just running your Python program, you see at the center button that we can run sbatch job.sh. So you'll always write an sh script in order to run your job. This script consists of 3 parts. Most importantly, at the very beginning, you specify the resources you need. They are always specified with the sbatch parameter. You can give your job or your script a custom name. And then you can add as many parameters as you like. For instance, I've added nodes or also like the task per nodes. You can even add CPUs per task or like how much memory you want to have per CPU. If you don't exactly know what you need, you can also leave some parameters out like the memory per CPU, and the scheduler will just take the default values. There's also the option to say that you want to be notified by email when your job begins and when your job ends. Just specify with mail type all and also with a mail user. Secondly, we have the environment preparation. Remember that you have a free session, so you always need to load Anaconda and also activate your Conda environment. Thirdly, execute your Python script with Python. Remember, you'll always have these 3 parts in your job sh script. First, the resources that you need with sbatch. Secondly, preparing the environment. And thirdly, just running your script. So let's see how this looks in live code. Let's go with the example that we've already defined and debugged a training script. We want to train a neural network. Essentially, the first part is similar to what we've seen before. We give it a job name. Well, we estimate maybe the training will take 5 hours. And remember this session on the partitions, we want to put this on the greater shared partition. Well, let's just grab 1 GPU and also be notified when our job begins and ends. Additionally, I've set 2 parameters, which is output and arrow. Because our program can't really print to standard out as we would get on the shell or standard arrow, we can redirect these, and I've redirected it to Slurm files here. And Slurm and %x gives me like the job name, and %y would be the job ID. So I can always check these files in case, well, both in case if it goes right and also if it goes wrong, maybe check the standard arrow. The second part is also similar to what we've seen. We load the environment and activate our Conda environment. I have one additional part in here, which is debugging. I really like it for my script to give me a Python version and also like the environment it lives in, and also the current CUDA version that I'm using. This makes it really easy for me to look for the correct information if something went wrong with the environment. And there I can run the script. Let's execute it. Again, I'm on the front end on the glogin 9. And there we go. We get the job ID and we get the information that we submitted the script. We will receive an email when the script starts, but we can already peek at its current status via the command line. With squeue, you can get the information of all your current running or waiting jobs. We see again the job ID, the partition, the name, well, I'm Nipsomber, and our job is already running, so I should have received already an email. What does happen if I know, well, maybe I look through the code and I find another error, and I don't want this job to run for 5 hours. We can always use scancel with the job ID to cancel the current job. If we look at this again, we see now that our job has been cancelled.